Hey, I hope it's going well. I wanted to put together just a short tutorial video here to talk a little bit about MyBlocks. So, what they call a procedure um, in the AP create task, what we can call a function. All those words are technically referring to the same thing, which is it's basically a block where you put a set of instructions in it, and then when you run those, you want to run those instructions, you simply place a call to the block. Let me hide this here for a minute. So I've I think the biggest, this is one of the biggest tasks. The other one being the list for your application, for your project, is figuring out when you need one, and actually even I guess more than that is finding or creating the need for one. So here I have I've kind of set up the Pong game. I made uh, 5 sprites. The first one is simply a circle. The second one is a rectangle. Notice it's right here. And then I duplicated that rectangle to get the left paddle. So right paddle and left paddle. I made a top wall, which I should probably center. Oh, let me undo that. Not centered here. Let me center it. There we go. It does move it here, but I can just move it like that. There we go. I also made a bottom wall, which again, it was not centered. So let me center. There we go. And it moves it, but I can just kind of slide it there. Okay, that looks good. So I've basically drawn 5 sprites. And the question then becomes, well, can I find a need for a MyBlock? Is there something that you're going to be doing repeatedly that consists of more than one instruction? So I guess maybe that's a good way to think of it. Is there something happening in your project that could happen once, and then maybe down the road it happens again, and then maybe down the road it happens again, and each time it's triggered by something different. So I'm looking at this game, and there's one thing that this ball is going to do. I'm going to call it a ball, not a circle, and it's going to bounce. So it's going to be bouncing off of the paddles and off of the top and bottom wall. It is not going to bounce off the left edge of the screen or the right edge of the screen. If it goes past the left edge or past the right edge, then the ball should basically delete itself. It should be gone, hide the ball, if you will. So bouncing is going to happen here, and there's going to be probably more than one block to get this ball to bounce. So there's probably more than one thing that it needs to do. So here is a good example of where I haven't written no code yet, none whatsoever. And I'm going to start here by creating my block. I'm going to create a MyBlock. Notice I'm in the ball sprite. I'm going to call it bounce. I'm going to add an input here because I could be bouncing off of the paddles or the top and bottom wall. And maybe depending on whether I bounce off of the paddle, either of the paddles or the wall, maybe something has to happen a little different. Now, this is right now me just thinking, okay, because I'm not sure if this is going to work out. I guess I shouldn't say that, I guess, but it's true. When you're working on a project, you're not sure if it's going to work out the way it should, but the best way to test it is to give it a try. So I'm going to call this here boundary. So bounce off of a boundary. You can call it wall, you can call it paddle, but I think boundary is a little more generic. So I have this bounce. Okay. Now let's find somewhere to call the bounce, or a way to call this bounce block. Notice there's no code in it yet, but we'll put some code in here. So let me start here by saying that forever, if I touch, if the ball touches either of the paddles, so I'll put here right paddle, if touching right paddle. Now, I don't know if again, we're testing this out, so I'll put here right paddle, and then I'll do a duplicate this and put here left paddle. But I might be able to combine these two. I don't know yet. But if the ball touches the right paddle, then we want to call the bounce function. Basically, we want to run the code in the bounce function. If it touches the left paddle, we want to do the same. And then if it touches the top or bottom wall, again, we want to do the same. So I'm going to duplicate this, put here top wall, and then bottom wall. Now, the reason I know for a fact that I need to differentiate the code depending on whether it touches either of the paddles or the top or bottom wall is because suppose that it touches the paddle, then we can think of that as increasing the score. The score should go up. And so maybe if it touches the wall, it won't. So that's what this parameter might help us do. Like say every time it touches the right paddle, we're going to send a 0 to bounce. Every time it touches the left paddle, maybe we'll send a 0 as well. And then if it touches the top or bottom wall, we'll send a 1 and a 1. Now again, we can start this off like this and change our code as necessary. I'll put here a flag to get all this started. Right now there's no motion for the ball, so we really haven't done a whole lot. But let's add some motion. So let's say that when the flag is clicked, now the motion for the ball here is going to be a little different. We're going to be moving, and I want you to notice what happens when I click on move. The ball moves, but it moved like down, and that's because if you turn, the ball moves in a different direction. Now this is turning basically the direction of the ball. Now, that's convenient because when we bounce, we're working with angles. So let me position the ball back here. Let me say that initially the ball is pointing to the right, which is 90 degrees. Okay, we want that. And let's just have it move 10 steps. I want to see if this works. Okay, that worked. Fine. Perfect. So the ball can move to the right. That's working fine. I'm going to actually maybe initially put it at an angle here, like 135. Let's do that. Notice it does move at an angle 135 degrees from vertical, which means from here 135 degrees this way. So that's working fine. Let me also position it when we first start this game. Let's put it at 0, 0 right in the middle. Okay, so this is working. There, it moved it. It also, okay, this is working fine. I think I'm going to write a separate algorithm to get the motion here for the ball. Again, we haven't quite worked with the bounce block yet, the MyBlock, but we will address that in a minute. So this is what I'm thinking. I'm going to forever move this ball in the direction it starts off in, so maybe 135, or I think 135 might, okay, it's fine. 135 is fine for now. Move 10 steps. So let's do that. Let's put that in forever. Actually, point to 135, move 10 steps forever, and we'll do that when the flag is clicked. Bam. Okay. So it works. It goes pretty fast. Let's kind of slow this down. 5. Much better. Okay, now notice that it actually hits the wall down here. So it should trigger this bottom wall. It hit the bottom wall. When it hits the bottom wall, what do we want to do? Well, let's think a little bit in terms of math. Let me actually come in here and do a little bit of drawing here. AP Computer Science Principles. We'll do here something like a bounce. But let's think about the math here that's happening. I'm going to draw. Let me change the view here. Okay. So the ball is coming in. It's coming in hot. Isn't that what they say when it's coming in fast? At 135 degrees from vertical. Actually, this is going to be much easier if I detach computer here. So it's coming in hot at 135 degrees with respect to the vertical. Let me do this justice and actually draw. That's actually exactly how I wanted to draw it. So this happens to be 135 degrees. And when it bounces, then we start thinking, okay, well, how is it going to bounce, you know? At what angle is it going to bounce? And I'm thinking it should be like 45. So I'm thinking this should be 90 degrees. Now we can actually not just assume if this is 135, this angle, and then if I was to draw two parallel lines, there you go. I know I'm teaching geometry for something. That one and that one. And I was to look, okay, well, let's look at these angles. How do they break up? Well, if that's 90, then that has to be 45. And that angle is the alternate interior angle with this angle. That's 45. And it's going to bounce off at the same angle it came in. So that should be 45 degrees. And if you add everything up here, 45 plus 45 is 90, plus 90 is 180. So isn't that crazy, right? There's some math here. Maybe I should have my geometry students work on the Pong game. It's not a bad idea. So then we start thinking, okay, well, how do we then make this angle? Because we need the ball to turn. That's what we're going to do. It's coming in at 135 degrees. I've convinced you that that pink angle should be 90 degrees, but we don't measure the angle with respect to the incoming line. We actually measure it with respect to the vertical. So here, we want the ball now to turn this way. We want that angle. Well, we know this is 45 degrees. That was a straight line, so this has to be 45 degrees. And what did we do? We turned, if this is counterclock, we turned 90 degrees counterclockwise. If you subtract 90 from 135, you get 45. Now I'm going to try it for the bottom wall. I guess we should then think about whether it's going to work for all the walls, but for now, let's try it for the bottom wall. So what do I want to do? I want to turn 90 degrees counterclockwise if I hit the bottom wall. I'll come in here. I'll say, here's the bottom wall. We're actually gonna send a 2 right now for now, or 1's fine. 1. And then I'm gonna come in here and say that if boundary, which again takes the value of the argument, so it's gonna be 1. Forget about the other ones for a minute. If boundary equals 1, we'll go in here. So when you call the block here, if boundary, which is that one, we go to operators equals 1. We know we hit the bottom wall, and so we're gonna turn counterclockwise 90 degrees. I don't know if this is gonna work. Let's try it. Boom. Interesting. Now I can try to look, and I can do it right here. If I'm coming in here, and this is what, 45 degrees, and then I turn 90 degrees counterclockwise, I'm going to point. I think this might work for everything we touch. So it might also work for the paddle. Let me do this one more time. Okay, let me position the paddle like right there, because it looked like that's where it hit. Let me do that here, that we come in here. We're going to say if, well, let's try this. Anytime you call the bounce function, let's just turn 90 degrees. Oh, it works. Okay, let me move this a little down. Let's try one more time. Oh, it's working. It's looking good. Okay, I like it. So right now, I don't have a need for this. And again, that's, I guess, my point is that when you start testing this and you start seeing how this should work, notice also that right now my block, the bounce block, consists of a simple command, one command, which is not ideal. You want to have multiple commands. As a matter of fact, the requirement is that you have an if statement, selection, and iteration looping. So right now, this is not quite addressing all those needs. However, I can do the following. I can create a variable called score. For all sprites, it's good. Score is 0, but when you hit either of the paddles, it's going to go up by 1. And so then we say, okay, well, let me consolidate some of this, because we saw that maybe we don't have to differentiate between these. Oh, I mean, it's meant to go in there. So let me use an OR operators. We're going to use an OR here. If you touch the right paddle or the left paddle, bounce and send it 0. If you touch the top wall or the bottom wall, send bounce a 1. And we'll say that when we bounce, we'll say that if the argument here, 0, which is going to be stored in the variable boundary, the parameter there, if it's 0, increase score by 1, otherwise don't. So we'll put here if, oh, excuse me, if boundary equals 0, that means that we've hit either of the two paddles. Then we want to change score by 1. Change score by 1. We want to initially have score equal to 0. There it is. It changed only when it hit the paddles. 2. It should have be set back to 0, but it didn't. Okay. Something's a little off there. But notice here, this algorithm is to get the ball moving. It is forever going to move 5 steps, so it's always going to be moving. But if we touch either the right or left paddle, we're going to bounce. If we touch the top or bottom wall, we're also going to bounce. Bouncing right now is very simple. It's just turn 90 degrees. That changes the direction of the ball. It's still going to then move 5 steps when it changes direction. However, if the boundary that has been touched is 0, which happens with the left and right paddle, because that argument is 0, we change the score by 1. Now, could this potentially be in a separate algorithm? Yes, it could be, but it wouldn't then address the need. Could you have some algorithm up over here that says if it touches a paddle, increase score by 1, or could you have this? I guess you could technically have it here. And then there's no need for a parameter. But then you're not addressing the requirements. And so you have to address the requirements, right? The requirements is that you have a parameter, that there be repetition in here. And so again, a challenging task, but if anything, here's an idea of how it might be addressed. Alrighty. I'll have a follow-up video here to talk a little bit more about the completion of this project, and then trying to find ways to incorporate a list. But yes, it is challenging.